All right, here comes the third of our five logical connectives. This one is called not, or negation. And the symbol is like this. Sometimes people use other symbols like a wiggle or an over bar, but we are using this. Make sure you use the symbol for the course. So here's how it works. If you have a proposition, then you can stick one of these symbols, a negation symbol, in front of it, and this will be a proposition. So this is a proposition. And that's the grammar of the symbol. That's all there is to it. As far as what it's supposed to mean, the semantics is, so if phi is a proposition, then this says it is not the case that phi. And I will often just read this as not phi for short, but that doesn't usually make grammatical sense. That's just a shortening. Really, it should be, it is not the case that phi. So for example, if phi is the sentence, snow is white, then this would be, it is not the case that snow is white. It wouldn't make sense to say not snow is white, right? That's not correct English grammar. It is not the case that snow is white. So that's negation. Now, if you can prove phi, then we say that phi is true, right? If you can prove phi, then we say that phi is true. If you can prove not phi, or it is not the case that phi, if you can prove not phi, then we say that phi is false. So this kind of gives a meaning to the word false. So we had already given a meaning to the word true. Phi is true, we're going to interpret as meaning you can prove phi. Phi is false, we're going to interpret as meaning you can prove not phi. So if not phi is true, then we say phi is false. And now we have this word false. If someone ever writes not phi, it is not the case that phi, we take that to be the same as phi. So you can take this to be sort of one of the rules, but it's just not, I'm not making it prominent enough that it has its own number. So this is the same as phi. Now that we have the not, or the negation symbol, we can do the following. We can make ridiculous sounding sentences like this: phi and not phi. Anytime you write something like this is called a contradiction. So, for example, snow is white and snow is not white, right? Snow is white and it is not the case that snow is white. Or snow is white and snow is not white. That's a contradiction. These are considered to be so bad, if our deductive system lets us deduce one of these, then the entire thing is broken. These are considered to be so bad that we have a rule, our rule of logic, that says that anytime some assumption leads you to deducing a contradiction, that assumption cannot be true. So let's make that official. So here's an official rule of logic, rule 2. Proof by contradiction. If assuming phi allows you to deduce a contradiction, then it must be that not phi. So this gives you a way of proving that something is not the case. So say you want to prove that snow is not white. Then you can start by assuming snow is white, then see if you can deduce a contradiction from that. For example, you might deduce that some cake is both flavored with chocolate and not flavored with chocolate. That would be a contradiction, and then you can go and say, okay, so snow couldn't have been white, as we assumed at the beginning. All right, so here's a sort of template that you could follow when you're writing out a proof by contradiction. Say you want to prove it's not the case that phi, then you assume the opposite. So in order to prove it's not the case that phi, you can assume phi. And this is an assumption. So the language being used here is very important. We're assuming that phi holds. We're not concluding it, right? It's an assumption. Then from that assumption that phi holds, see if you can convince the reader of your proof of some contradiction. Any contradiction, so anything of this form. If you can do that, then our rule, Rule 2, says that it's valid to now conclude the opposite of what was assumed. And you don't need to put this long phrase here for the sake of obtaining a contradiction, but it really helps to put it, because it helps signal the reader that we're making this assumption for the sake of applying Rule 2. Alright, so you will see this used a lot. We will use this rule a lot. You will see many examples, and it'll hopefully make more sense the more you use it. So these are contradictions. Now, another interesting thing that we can form is, instead of phi and not phi, we can look at phi or not phi. So, for example, either snow is white or snow is not white. That should not sound like a contradiction at all. That sounds like a perfectly sensible thing to say. Snow is either white or it's not. In fact, that's true if you believe that snow is white, right? Because if you know either side of the or, then you know the whole thing. We actually are going to declare as a logical rule for our deductive system that these are always true. So you can take it almost like it's a family of axioms. Any proposition of this format is just accepted as true. So this is a rule, and I'm calling it Rule 3. And it's called excluded middle. So that's telling you there's no middle ground. Things are either true or false. You can't be something in between. You can't be neither true nor false and try to be something else. So a proposition either is true or it's false. So the rule literally just says this. And the idea is that you can apply it to any proposition. So for example, by Rule 3, it is true that snow is white or it's not white. By Rule 3, it is true that cake is either flavored with vanilla or it's not flavored with vanilla. And we will see in a moment how this rule allows us to really restrict what are the possible things that can happen for any particular family of propositions. Not everybody actually accepts this rule, so in standard mathematical logic it's accepted. Pretty much all mathematicians accept this as part of their logical system. But there are people who enjoy playing with logical systems where this is not accepted. And they end up being able to conclude different things than what we can conclude with our normal, with this standard system. So, you don't have to accept that propositions are either true or false. You don't have to accept any of the rules. But this one in particular, you can really get away with not accepting. You can allow things to be sort of not necessarily either true or false. But we do accept it, as do most people.